Hi guys, this is Mrs. Gessler, and in this video I'm going to talk about how to write electron configurations. You're going to need a couple of things that we're going to talk about. We're going to talk about these colorful periodic tables here, and you're going to need your periodic table that has some information on the back, including this chart right here, and then we'll get started. So we're going to do a couple of examples first, and then hopefully you'll be ready. Okay. All right, so I filled it out a little bit. If you need to stop it so that you can catch up, that's okay. Put your name, date, and class period here. We're going to be doing Objective 5.6, where we talk about writing electron configurations. Our main question here is, what is an electron configuration and how do I write one? So to begin with, what is an electron configuration? Well, electron configurations describe the location of electrons in an atom. It's a little bit like an address in that we know exactly where they are, but in addition it's a little bit like a census because we know how many there are. So we're counting them and saying where they're located. Now I've got an example here. Don't get too upset about this. This is the longest one ever. Actually, I ran out of room, so it's not even the longest one ever because I couldn't put everything on it. But it's got big numbers on it, and it's got letters on it, S, P, D, and F, and then it's got some little numbers up high. Now, you might remember that when we talk about the orbitals, S, P, D, and F are the choices, and there's an S in the first energy level, an S and a P in the second energy level. There's the S, P, and D is over here for the third energy level because those energy levels begin to overlap. The fourth energy level has S, P, D, and F, and again, there's overlapping in those levels. So this is what the electron configuration looks like. So what do those things mean? Well, this large number right here, the full-size number, tells you the energy level that the electron is in. So in this one that I stole from right here, okay, these electrons are in the third energy level, 3 for third energy level. Now this letter right here, which is lowercase, we're not writing any capital letters, lowercase letter, this happens to be the orbital or the sublevel. So we're in the third energy level and we're talking about the p orbital. Now this number here is a superscript number, which means it's little and up high, superscript number. That tells you how many electrons are there. So in this particular electron configuration, I have 6 electrons in the third energy level in the p orbital. So this one up here, I could pick any one of these. There's 2 in the 5th energy level in the s orbital. So that's what the electron configuration tells you for each of the electrons. It tells you where they are and how many there are there. So how do you write an electron configuration? Well, we've got an example here. What we're going to look for is the one for gold. Now, we're going to make use of the fact that we know some good patterns for the periodic table. We know that the energy level is the 1, 2, like that, the 3 dips down, the 4 dips down even further, and 5 and 6 and 7. And then we also know that all of these guys have their last electrons in the s orbital. This is the d orbital, the p, and the f. And an interesting thing to note is that you can fit 2 electrons in the s orbital, so it's 2 columns wide. You can fit 6 in the p orbital, 1, 2, 3, 4, 5, 6 electrons in the p orbital. And then in the d orbital, you can fit 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Interesting. And then the f orbital, which would be right here, has 14 electrons that it can hold. So 1 column for each of those 14 electrons. It's kind of fantastic that it works out that way. But that is part of the reason why the periodic table looks the way it does. So these two things combined is where we get this chart on your periodic table from. Now you might notice here it says 1s2, 2s2, 3s2, 4s2. This is the S block. In case you ever forget, that's the S block. Here's the D block. See, the arrow goes all the way to right here. And then this is the P block. This would have a 7P on it also, all the way across there. And then here we have the 4F. It's got some numbers on it, and we're going to be paying attention to some of those numbers some of the time, so we'll talk about that. A note you might make is that helium is over here in this periodic table because it's in the S block. Okay? So the first thing we're going to do to find gold is we're going to find it on the periodic table so that we can find it on the chart. If you can find it on here, that's great. If not, find it on here first. Gold is number 79, so it's right here. So at this corner here, I'm over 2 and down 3. So at this corner here, over 2 and down 3. Here is gold right here. Okay, so this is the one I want to write the electron configuration for. So the next thing I'm going to do is I'm going to use this chart and I'm going to read the electron configuration and write it down. So just like I read a book, I'm going to start at the top. I'm going to go left to right, down a row, left to right, down a row, left to right, down a row. And the only thing I have to remember is that right here, I have to go down here and then come back up. Okay? So for gold, I'm trying to get here. So I'm going to start up at the top, 1s2. 2s2, keep going across, 2p6, 3s2, 3p6, 4s2. These little numbers that I'm writing down are right here on the chart. If I forgot or I didn't know where they were, I could just count up how many boxes there are. So this is after 4s2, there's 10 across here. It's the third energy level, and this is the D block, so 3d10. And then I've got 4p6, 5s2, 4d10, 5p6, 6s2, and now here I have to remember to go down to this block here, the F block, 4f14. And now my gold is not all the way at the end, so I made a little place. If it's not at the end of the row, then I'm going to have to count to get the number. So I'm starting here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be 5d9. Okay, so I've got, I'm going all the way across to here. I know this is 10, maybe I could have counted backwards, but that's all I'm doing to read my electron configuration. So count to get to the element in question. Okay. I should finish my sentences. Okay, so that's how you write an electron configuration. It definitely gets easier the more you do it. So I've got a couple more examples for us to look at. One where we're actually writing the electron configuration and another where we're going to look at a difficult question. Okay, so now I need to write the electron configuration for silicone. Silicone is Si, so the first thing I need to do is find it. Silicone, Si, right here. So it's 2 in from the corner there. 2 in from the corner. There's silicone right there. So this is the one I'm going to be doing right now. Okay, so the next thing I have to do is read it from the periodic table. Find it, read it. Silicone. Start at the top. 1s2, keep going, 2s2, it goes across, remember it goes across this way here in these blanks, 2p6, 3s2, and now it's not at the end, so I have to count, 1, 2, 3p2. It's pretty easy, right? The further you get down, the more you have to write, but they're still pretty easy. You just keep reading across the periodic table. One thing that people like to do is they like to try and dip down, so they would write 3s2, 3d10, 3p6. Don't do that. We don't skip rows when we read a book. We don't skip rows when we read the periodic table either. So you have to go straight across. Okay, so this next one I thought would be kind of fun to do because then we can kind of test our knowledge just a little bit. This question says, which of the following is the correct electron configuration for titanium? Now, I don't know about you guys, but when I have to pick one of the following that is correct or isn't correct, I try to find the one that's different. So I see here that they all start off with 1s2. They all have 2s2 and then 2p6 and then 3s2. And then I start to get to a difference. So if I were going, the other thing I could do is just write down the configuration for titanium, but I kind of like to point out the mistakes here. So I got to find titanium. Where is titanium? Ti, there it is, titanium. Okay, so it's the second one over from that little gap right there. Second one over, there it is right there. The arrow's going through it, so it looks like it says something else, but there's titanium. Okay, so I'm going to start here. They all started 1s2, 2s2, 2p6, 3s2. Now, this one here with the 4s2, I skipped a level, so that's not right. So I know it's not B. In fact, after 3s2, I got to go all the way across to 3p6, which the rest of them do. And then I got to come down here. This one has 4s2 first, which is good. That's what should come next. This one has 3d10. This one here is trying to take advantage of the fact that those are switched. It doesn't go all the 3 levels and then the 4. Remember, those levels overlap, so they're not always in the right order. So this is not coming next, so that's the wrong answer there. So 4s2 is still okay. And then the next thing I need to write down is either 3d10 or 3d2. Well, 3d10 would be what I would write down if I went all the way across. But I stopped at titanium, which is 1, 2. So it's the 10 right here that's wrong. It should be 3d2. So D is the correct choice. Okay? So listen, you got to write electron configurations in order to get good at it. So there's plenty of them in the homework packet. Do make sure you practice. Ask for help if you need it. Thanks for watching.